All right, we're still doing chapter 1, section 4. I'm doing the guided practice problems that are on page 30 of the textbook, which is page 29 or maybe 31. I should check that. But you can find it in the PDF if you want to look for it. And we're doing problems 3 and 4, which is just like the previous video where we are evaluating an algebraic expression and simplifying it. And again, I just really, really want to emphasize, if we learn what is actually happening, then it's going to make us understand more complicated problems when they come up. Truly, there's really nothing that we do other than counting in math. It's just sometimes there are things that become almost impossible to count the way we would count in first grade. But the same process actually is still there. All right. So again, it's more about the process, not the solution. Someone shared with me this really lame video. Again, that's what people do. They send me stuff like, "You're a math teacher. Look at this." Comparing multiplying the way that person learned in school to how like students are being taught now with a lattice method or a multiplication box. And in the video, I'm not going to talk too long about this, but in the video, it's split screen where the teacher explains on one side, and on the other side, some dude gets the problem, and then he goes and he fries an egg and he does something else. And it's a real passive aggressive way of saying, I could have had the answer the whole time. Well, what's frustrating about that is that in the part where they're explaining how to do it, the quote unquote new way, that's actually helping you learn polynomials, which come up a little bit later. And when we get to polynomials in chapter 6 or chapter 7, I'm sure that I will come back to that discussion. But it's just frustrating because we want students to understand, not necessarily just like vomit out an answer. All right. And if we were in class together, this is like one of the best places to have a great discussion about why we learn math. Right now, it's just me talking to myself in the basement. Okay. All right. So let's do these two problems real quick. Like I said, this is problems 3 and 4. I got a squared, so I got a squared plus b squared. Subtract 2 times a times b. This actually means something, but we're not going to worry about it later. My a's are 5. Each a is 5. And my b is going to be 8. So I'm going to take care of exponents first. 5 squared is 25. 8 squared is 64. Now, I could skip because multiplying here, even though it's not exponents, doesn't affect this, but I'm going to do it in separate steps. I get 25 plus 64. 2 times 5 is 10, times 8 is 80, so subtract 80. And again, that's plus negative 80. And you can do however you want to do it, okay? 25 plus 64 is 89. 89 plus negative 80 just equals 9. Notice I didn't write any equal sign anywhere. Excuse me. I'm talking too much and my throat is getting dry. I'm going to have to take a break after this video. And also notice that my process keeps getting smaller and smaller. I'm going to end up with like this type of a shape. Like I don't want to call it an upside down triangle, but that's what it is, like a funneling. I'm funneling down to just one number, one value. That's what I want. One other thing I want to mention, I forgot to mention this in the other video, we talked about this. These happen at the same time. Multiply, divide happens at the same time. Change your division into multiplying by the reciprocal. Add and subtract, change your subtraction into adding the opposite. I left off this, and it's in the video, but parentheses actually mean do that part first. So if you see parentheses around something, like if I said 4 times 2 plus 9, even though I'm supposed to multiply before I add, the parentheses say nope, add first. These parentheses over here, I did remember saying parentheses are like a workhorse in math. We use them in lots and lots of different places. We love our parentheses. We use them for multiplying. We use them when we're talking about graphing. I want you to graph 2, -3. All right. We also use them when we say we want to do something first. We use them also with substitution. So when I substituted here, it also became multiplying. So that's part of the language of algebra that we have to learn before we can actually do any algebra problems. All right, skip down to number 4. I get 3xy over x squared minus 9y plus 2. My x is 2 and my y is 4. So I'm going to get 3 times x times y over x squared minus 9 times y plus 2. Excuse me. X equals 2, so this x equals 2 and this x equals 2. Y equals 4, so this y equals 4 and this y equals 4. I'm going to go sideways with this one. So I'm going to use an arrow, say, instead of me going down, I'm going to go to the right. This line, sorry, hiccups. This line right here is what we call a horizontal division bar. And a horizontal division bar has hidden parentheses. So everything in the top has parentheses around it, which means I have to do everything in the numerator first. And everything in the denominator I have to do first before I take the top and divide it by the bottom. So in the top I get 3 times 2 times 4. That's either 6 times 4 or 2 times 8 or 12 times 2. All of those equal 24. In the denominator, I got to do some steps. 2 squared is 4. I'll put these together. 9 times 4 is 36, and then add 2. I'm going to keep working with the bottom. This is, again, plus -36. Squeeze my plus sign in there. So 4 plus 2 equals 6, plus -36 is going to be -30. And this, I'm not going to like divide, but I can simplify this by reducing this fraction. This is going to equal -4/5 because there's a common factor of 6 in both the numerator and denominator. Okay, I know that a lot of this is review, but like I said, I really go into this when we are in person in class to really get down at understanding what's happening with the math. So I don't want you to be too stressed out about that or anything. Remember that we're learning skills that are going to help as we go further in this section or in this class. Bye.